Bismillahirrahmanirrahim. Assalamu alaikum students. I hope that you all are fine. I am here with the lecture 7 of physics from unit 2 kinematics. The name of the topics which I am going to teach you today are speed and instantaneous speed. Student, speed means how fast or slow a body is moving. In physics, we define the speed as distance covered by a body in a unit time. Here, I represent the definition in the form of a formula. Speed is equals to distance covered divided by time. Symbolically, speed is represented by small v. Distance covered is represented by delta s, and time is symbolically represented by delta t. Students, this triangle is actually a Greek letter. It is pronounced as delta. It shows a difference between the quantity at the final position and at initial position. If we remove delta in a formula, then we can write the formula like this. Distance at the final position minus distance at the initial position divided by time at the final position minus time at the initial position. You cannot write initial distance first and then final distance. That method is wrong. You always write final distance and final time first, then write the negative sign and then write the initial distance and initial time. This is the symbolical representation of speed. Students, as you see from equation 1, if we find out the unit for the speed, then speed is equals to the SI unit of distance is meter divided by the SI unit of time is second. So meter per second is the unit of speed. We can write it as you see girls, that here the second has a power of +1. Here nothing is written. It means that +1 is present over the second. If I move this second from denominator to the numerator, then we write it as this, meter per second. This negative sign shows that second is present in division. Okay, so meter per second is the unit of speed. Now I explain the concept of speed to you with the help of an example. For example, here the car is standing. The car is not changing its position, it is at rest. So at this starting position or initial position, the initial distance is 0 meter. And here the initial time is also 0 seconds. After some time, we observe that the car is changing its position and it has covered a distance. So at this final position, the final distance which the car has covered is 4 meter, and the time at this final position is 2 seconds. So if we find the speed with which speed the car moves from initial to final position, we proceed as follows. Here I write the formula for finding the speed. Final distance minus the initial distance divided by final time minus initial time. Now I put the values in this formula. 4 meter minus 0 meter. Final distance, initial distance divided by final time minus initial time. Now V is equals to 4 minus 0, 4. We take the meter common, and 2 minus 0 means 2, and we take the second common. The answer is 2 meter per second. So the speed with which the car covers a distance of 4 meter in 2 seconds is 2 meter per second. This is how we can find the speed of any moving body. Students, as you see that the speed only gives the information about the number and unit, it means that it only gives the information about the magnitude. So speed is a scalar quantity. Scalar quantity. Scalar quantity. Here I remove L. This, yes, it is a scalar quantity, and it only represented by a magnitude. It is only represented by a magnitude. So it is all about the speed. Now our next topic is the instantaneous speed. The word instantaneous is actually taken from the word instant. Its Urdu meaning is lamha. Instant is a very short duration of time. So we can define the instantaneous speed as instantaneous speed is the speed of the body at a particular instant of time. At a particular instant of time means at a very short duration of time. First, I write its formula. Students, you are familiar with the formula of speed, delta S divided by delta T. But when we are writing the formula for instantaneous speed, we write it as limit delta T approaches to 0. Limit delta T approaches to 0 here means that the delta T is taken very small. Is taken very small. It means that the delta T is close to 0. It is close to 0. It is close to 0. But that delta T is not equal to 0. Okay? It is not equal to 0. It is a very small interval of time. Suppose I start walking. Okay? This is the path which I follow during the walk. This is the path which I follow during the walk. Suppose I start walking. When I take first step, okay, for example, I am standing here and I take the first step. At that moment, you see that I have covered a very small distance in a very small interval of time. So at this time interval, at this instant, the speed which I measured is actually the instantaneous speed. Students, now I explain the concept of instantaneous speed with the help of another example. If you are going to Islamabad, during your journey, you look at the speedometer of the car. At that particular moment, what you read from the speedometer is actually the instantaneous speed of your car. Students, you have noted that the needle of a speedometer does not stay at a single value. Students, you also observe that sometimes your car moves faster, so the needle of the speedometer moves towards the higher values of speed. And when your car slows down, its needle moves towards the lower values of speed. So, speedometer of the car represents the change in speed for within a very small time interval. For a very small time interval. So, speedometer of the car gives the description of motion of a moving body at every location of the path of motion. Students, you must note it that speedometer of the car measures the speed in kilometer per hour. Students, now I am giving you a brief revision of the important points of these topics. Students, speed is defined as the measure of the distance covered with the passage of time. It is denoted by small v. Its formula is speed is equals to distance divided by time. Speed is denoted by small v, distance with delta s and time with delta t. If we remove the delta, then we have to write this formula as distance at the final position minus distance at the initial position divided by time at the final position minus time at the initial position. The SI unit of speed is meter per second. It is a scalar quantity because it has no direction and it is only represented by its magnitude. Instantaneous speed. We define the instantaneous speed as instantaneous speed is a speed for a short interval of time. Its formula is V is equals to limit delta t approaches to 0. Delta is divided by delta t. Here limit delta t is approaches to 0. It is very close to 0, but it is not equal to 0. As it is a speed, so its unit is meter per second. Speedometer of the car gives the information about the instantaneous speed of the moving car. So speedometer of the car shows change in speed within a fraction of a second. Class, this is the end of my lecture. Thank you very much.